Good evening, ma'am.
Good evening, very good evening.
Ma'am, I have a small doubt.
Yes, Peter, tell me.
In the previous classes, when you were giving the notes, I found it a little hard to follow. So,
Means,
meaning I kind of got lost in the middle because you
Beta,
were
your
only
voice is
dictating.
cracking. Beta, your voice is cracking. Arjun,
Uh,
your
yes,
voice
ma'am.
is
Can you hear
cracking.
me now? Hello? Can
I
you hear
can
me
hear
now?
you, but Beta, I can hear you, but your voice is cracking.
Uh, okay.
So coming to your next topic, last time we completed up your electromagnetic forces, right? So the next type of the forces which we are having is your nuclear force. Okay. I told you that there are two type of nuclear forces. The first type of the nuclear force is strong nuclear force, and the second type of the nuclear force is your weak nuclear force. Okay, nuclear forces can be divided up into two parts, into two categories. The first one is your strong nuclear force, and the second one is your weak nuclear force. Okay, so firstly, we are going to discuss about your strong nuclear force. Beta, somebody is unmuted. Please mute yourself. Some sort of disturbance is coming from your background. So next one is strong nuclear force. What is nuclear force? See, beta, in strong nuclear force, what we have when we are talking about your strong nuclear force. So in this, first of all, when we are talking about the nuclear force, the basic thing concerned over there is the nucleus. We are just concerned about the nucleus. Okay. When we are talking about nucleus, so nucleus is present inside the atom. Okay. So nucleus of an atom. Nucleus of an atom. Now, the nucleus of an atom contains protons. Okay. Nucleus of an atom contains protons. What are protons? Protons are your positively charged particles. Okay. Protons are your positively charged particles. And when we are talking about your neutrons, so neutrons are your negatively charged particles. Okay. Now, the nucleus is consisted up of protons and neutrons. Okay. Protons are positively charged particles and neutrons are negatively charged particles. Okay. Now, there is a force which is holding up the protons and neutrons inside the nucleus. There is a force which is holding up the protons and neutrons inside the nucleus. Okay, so that force is known as your strong nuclear force. Okay, that force. Ayush, are you able to join with your laptop now?
Yes, ma'am, I'm trying 1 second.
Okay, so that type of the force is known as your strong nuclear force. Okay, I'm repeating it again. When we are talking about the nucleus of the atom, so nucleus of the atom consists up of two type of charged particles. The first type of the charged particles are your positively charged particles, and the second type of the charged particles are your negatively charged particles. Okay, your positively charged particles are known as protons and the negatively charged particles are known as neutrons. Okay, so there exists a force which hold up the protons and neutrons inside the nucleus. That force is known as your strong nuclear force. That force is known as strong nuclear force. Okay, now when we are talking about your characteristic of the strong nuclear force, so what are the characters of your strong nuclear force? The first characters is that this nuclear force is very attractive in nature. This force is very attractive in nature. Okay, this force is attractive in nature. Okay, unlike your two forces, जो हमने दो forces last time की थी बेटा, your gravitational force and electromagnetic force, I told you that they were long range forces. Long range forces means they were acting till a particular distance. Okay, but your strong nuclear force is not long range force, it is a very short range force. Okay, very short range force. That means it is acting to a very shorter distance. That means only up to a distance of 10 to the power minus 15 meter. Okay, 10 to the power minus 15 meter. It is a very short range force. It can act only up to a distance of 10 to the power minus 15 meter. Okay, what is 10 to the power minus 15 meter? This is the size of the nucleus. Okay, size of the nucleus. So that means जो आपके strong nuclear force है ना बेटा, वो सिर्फ nucleus के अंदर अंदर act कर सकती है. It cannot act outside it. It is very short range force. Okay, third thing, third is it is 100 times stronger than the electromagnetic force. Okay, it is 100 times stronger than the, it is 100 times stronger than the electromagnetic force. Okay, and when we are talking about your gravitational force, so it is 10 to the power 38 times stronger than the gravitational force. Okay, when we are talking about the strength, so it is 100 times stronger as compared to that of your electromagnetic force, and it is 10 to the power 38 times stronger as compared to that of your gravitational force. Okay, now the next thing in your electromagnetic as well as gravitational force was that they were central forces. Okay, and this force is non-central force. This is a non-central force. Non-central force means it is not acting along the line joining the center of two particles. है ना? In that what we were doing, we were taking up two particles. है ना? So the force was acting on the line which was joining up these two particles. So it is a non-central force. It is not acting along the line joining the center of the two particles. Right. Next thing, it does not obey inverse square law. Okay. Does not obey inverse square law. Right. So it doesn't obey inverse square law. Right. So clear? So these are the characteristic of your strong nuclear force. I'm repeating it once again. Your strong nuclear forces are attractive in nature. This is the first characteristic. Second characteristic, they are very short range force. Okay, they are very short range force. They can act only up to a distance of 10 to the power minus 15 meter. So this distance is just nearly equivalent to the size of the nucleus. That means these forces can act only inside the nucleus. Right. Third thing, these forces are 100 times stronger as compared to that of your electromagnetic force. Okay, these forces are 100 times stronger as compared to that of your electromagnetic force. Right. Next is these forces are 10 to the power 38 times stronger as compared to that of the gravitational force. Okay, these forces are non-central force. That means they do not act along the line joining the center of the two particles. Fine. They do not obey inverse square law. Right? These forces do not obey inverse square law. Okay. So write it down, beta. Strong nuclear forces. Strong nuclear forces. Write down. The nucleus of an atom contains protons. The nucleus of an atom contains protons. The nucleus of an atom contains protons and neutrons force holding the protons and neutrons inside the nucleus, the force holding the protons and neutrons inside the nucleus is known as strong nuclear force. There you have written protons. In the bracket, you can mention positively charged particles. And for neutrons, you can mention negatively charged particles.
But don't neutrons have like they're neutral, right? They don't have any charge.
Uh, sorry. Yeah, neutrons are neutral. Wait, beta, wait. Yeah, sorry, beta. I made mistake. Neutrons are neutral. Why I'm writing it negatively charged particles? Sorry. Neutrons are neutral, uncharged particles. Neutrons are uncharged particles. In the bracket, write down uncharged particles. The force holding the protons and neutrons inside the nucleus, the force holding the protons and neutrons inside the nucleus is known as strong nuclear force. The force holding the protons and neutrons inside the nucleus is known as strong nuclear force. In the next line, write down characteristic of the strong nuclear force. Characteristic of the strong nuclear force. First characteristic, write down, it is attractive in nature. It is attractive in nature. Second characteristic, it acts over a very short distance. It acts over a very short distance. Which is approximately equivalent to 10 to the power minus 15 meter, which is approximately equal to 10 to the power minus 15 meter, which is the size of the nucleus. Which is the size of the nucleus. Comma, it is a short range force. It is a short range force. It is a short range force. Third, write down, it is 100 times stronger than the electromagnetic force. It is 100 times stronger than the electromagnetic force. It is 100 times stronger than the electromagnetic force and 10 to the power 38 times stronger than the gravitational force. And 10 to the power 38 times stronger than the gravitational force. After this, next write down, it is a known central force. It is a known central force. That is, it does not act along the line joining. That is, it does not act along the line joining the centers of the two particles. That is, it doesn't act along the line joining the center of the two particles. Next point, it does not obey inverse square law. It does not obey inverse square law. It does not obey inverse square law. Next point. Leave the next point. That's it. Okay. So this was about your strong nuclear force. Coming to the next type of the nuclear force, that is your weak nuclear force. The next type of the force is weak nuclear force. So what are the weak nuclear force? See, beta, whenever we are having radioactive decay, when we are talking about the radioactive decay, okay, what is radioactive decay? Whenever there is emission of the radioactive particles, okay, so before the emission of the radioactive particles, certain radioactive elements are acting together, okay, they are reacting together. So during that reaction there is some radioactive decay, okay. There are certain radioactive elements like your uranium, thorium. So these radioactive elements, they cause radioactive decay, okay. So the force between the elementary particles, the force which is acting between the elementary particles, which elementary particles? Which are emitted during the radioactive decay. Okay, the force between the elementary particles which are emitted during the radioactive decay of a radioactive substance is known as weak nuclear force. Okay, see, beta, I'm repeating, there is a force, okay, which force? Between the elementary particles. There is a force between the elementary particles. Okay. There is a force between the elementary particles. So this force between the elementary particles which are emitted during the radioactive decay, okay, radioactive decay of your radioactive substance, of your radioactive substance is known as your weak nuclear force. Okay, is known as your weak nuclear force. Now, whenever we are talking about your radioactive decay, so the first thing we are taking into consideration is your beta decay. Okay, the first thing which we are taking into consideration is your beta decay. So in beta decay, electron and neutrino, okay, are emitted. So electron is negatively charged particle, right? And your neutrino is uncharged particle, right? So whenever we are talking about your beta decay, let's say when we are talking about your beta decay, so during beta decay, the emission of the electrons and neutrino is observed, right? So electrons are negatively charged particles and your neutrino is uncharged particle, right? So these two particles are emitted out. These two particles are emitted out. So the force between an electron and neutrino, the force which is present between an electron and neutrino is known as your weak nuclear force. I'm comparing up the weak nuclear force and strong nuclear force. See, beta, in strong nuclear force, the force was acting between your protons and neutrons. There, the protons were positively charged particles and neutrons were uncharged particles. Here, when we are talking about your beta decay, so in this, the force is acting between your electron and neutrino, where neutrino is your uncharged particle. Okay, the force which is acting between the electron and neutrino is known as your weak nuclear force, is known as your weak nuclear force. Okay, now when we are talking about your weak nuclear force, so weak nuclear force is just having, when we are talking about the relative magnitude, so relative magnitude of your weak nuclear force is of the order 10 to the power minus 13. Okay, the relative magnitude is, when we are talking about the strength, so its strength is 10 to the power minus 13, right? When we are talking about your weak nuclear force. I'm repeating again, what is weak nuclear force? The force between the elementary particles which are emitted during the radioactive decay. Okay, your strong nuclear force was acting inside the nucleus of an atom. It was not required for the substance to be a radioactive substance. But here the substance should be a radioactive substance because radioactive decay can take place only inside your radioactive substances. Okay, so the force between the elementary particles emitted during the radioactive decay of a radioactive substance is known as weak nuclear force. Is known as weak nuclear force. Okay, so in beta decay, the electron and neutrino, neutrino is uncharged particle, are emitted. Okay, so the force between electron and neutrino is known as your weak nuclear force. Okay, and when we are talking about the magnitude, relative magnitude, so relative magnitude is of the order of 10 to the power minus 13 in this case, right? So write it down, beta. Weak nuclear force. Weak nuclear force. The force between the elementary particles, emitted during the radioactive decay, of a radioactive substance, is known as weak nuclear force.
Excuse me, ma'am.
Stop. Yes, beta.
Ma'am, can you please explain radioactive decay again?
What? Repeat.
Can you please explain radioactive decay again?
See, beta, what is radioactive decay? In radioactive decay, see beta, whenever nuclear reactions are taking place, so nuclear reactions में होता क्या है basically, आपका जो एक बड़ा element है, एक nuclear जो आप radioactive element ले रहे हैं, okay, उसको रिएक्ट करवाया जाता है. उसके बाद क्या होता है, वो जो आपका रेडियो एक्टिव एलिमेंट है ना बेटा, वो छोटे पार्ट्स के अंदर कन्वर्ट हो जाता है. दैट इज नोन एज रेडियो एक्टिव डिके. आपका एक बिगर एलिमेंट when it is getting converted up into smaller parts, so that is basically known as your radioactive decay.
ठीक है मैम.
अभी आपके लिए इतना ही सफिशिएंट है. It will come further in further units, so there I will explain. Okay, बस अभी आप ये समझ लो radioactive decay क्या होता है बेटा. Radioactive decay is basically a procedure जिसके अंदर क्या किया जाता है, एक parent element होता है, radioactive element जिसको हम बोलते हैं parent element. वो parent element को further divide किया जाता है daughter elements के अंदर. Okay, तो वो जब रिएक्शन होती है जिसके अंदर आपका parent element is getting converted up into further daughter elements, so that is known as radioactive decay. Okay, किसी एक आप ये समझ लो कि किसी एक बड़ी चीज को आप डिवाइड करके you are dividing it into smaller parts. After reaction it is getting divided into smaller parts, so that is basically known as your radioactive decay. इसको radioactive decay इसलिए बोलते हैं because it is taking place inside your radioactive elements. और radioactive elements को कभी भी हम normal room temperature के ऊपर we cannot store them. Okay, they are always preserved under particular certain conditions, because they are so reactive that they can even cause harm to the people who are living nearby. Okay.
Ma'am.
Beta, somebody else was speaking something.
Ma'am, this happens when the neutron to proton ratio is more than 1.6 in the nucleus, right?
Repeat.
The radioactive decay of a radioactive element happens when the neutron to proton ratio is more than 1.6 now.
Yes.
Ma'am, so do we have that in our syllabus in grade 11 or 12, or is it not there?
No, it's not there.
Okay,
Okay.
okay.
See beta, before that, every atom, let me थोड़ा सा बता देती हूँ मैं. Every atom seeks to be as stable possible. Okay. Every atom tries to be possible. Right? Means every atom wants to be stable. Okay. But in the case of your radioactive decay, the instability is occurring. The atoms become unstable. Okay. So when there is imbalance in the number of protons and neutrons in the atomic nucleus, okay, so there is too much energy inside the nucleus to hold all the nucleons together. To hold all the nucleons together. इतनी ज्यादा एनर्जी हो जाती है, ओके, इनसाइड द न्यूक्लियस. तो उस टाइम पे जो आपकी रेडियो एक्टिव रिएक्शंस होती है ना, वो हो जाती हैं. ठीक है. बेसिकली इसके अंदर क्या होता है, द नंबर ऑफ प्रोटॉन्स एंड न्यूट्रॉन्स इनसाइड द एटॉमिक न्यूक्लियस व्हिच आर प्रेजेंट ना, दे गेट इम्बैलेंस्ड. और उस इम्बैलेंस की वजह से क्या होता है, जो आपकी एनर्जी है वो बहुत ज्यादा हो जाती है. ओके. इनसाइड द न्यूक्लियस. तो जो आपका न्यूक्लियस है वो न्यूक्लियंस को इट्स नॉट एबल टू होल्ड ऑल द न्यूक्लियंस टुगेदर. ठीक है. तो उस टाइम पे आपकी जो रेडियो एक्टिव रिएक्शंस होती हैं, दे अकर, रेडियो एक्टिव डिके होना स्टार्ट हो जाता है. ओके. क्लियर बेटा? Am I clear?
Yes, ma'am.
I don't know who asked the question actually. Somebody asked this question. So am I clear, beta?
Yes, ma'am.
Okay, Vaishnavi. But some boy asked the question after you.
Yes, ma'am, it was me, Ayush.
Okay, Ayush. So am I clear now?
Yes, ma'am.
Ayush, am I clear? Okay. But actually, this topic is in detail. But here it's not in detail. It's just a matter of these two lines only. Okay. But for that, I have to explain you everything. Your alpha particles, beta particles, gamma rays, okay, ionizing radiations. I have to explain all these things. But these things are not required over here. So whatever the portions are required here, will complete up that only. Right? Okay. So I think I was dictating. In beta decay, electrons and neutrino, in beta decay, electrons and neutrino, yes, beta.
Ma'am, when you started weak nuclear force, you said of a radioactive substance is known as weak nuclear force. So from there only we have to continue.
Yeah, from there only continue. In beta decay, electron and neutrino. In beta decay, electron and neutrino along with neutrino in the bracket, you can write uncharged particle are emitted. Uncharged particle are emitted, full stop. The force between an electron and neutrino is known as weak nuclear force. Is known as weak nuclear force. So beta, if you are talking about the back exercise of your NCERT textbook, so this chapter 1 will be over today. Okay, so I will be sharing up all the solutions of the back exercise of your NCERT textbook, right? I want you to go through those questions. Okay, the complete back exercise I'll be sharing up with you. I want you people to go through those questions. If any doubt will be there, you can ask me in the next class. Okay, because now we are going to start up with your test as well, right? Before going to further more questions, I want to make this thing very much clear to you. All the back exercise questions of NCERT textbook are really very important. Really very important. So don't take them lightly. Okay. सबसे पहला आपका अप्रोच यही होना चाहिए कि you complete up your NCERT textbook. Okay. So complete solutions I will be providing you in PDF format. You have to go through those questions. If any doubt will be there, you can ask me in the next class. Okay. So coming to your next topic is conservation laws. The last topic of your this chapter is conservation laws. Conservation laws. Yes, beta. Now, when we are talking about your different type of units, okay. So different type of the quantities. First of all, we'll talk about the quantities, then we'll come to units. So when we are talking about the quantities like your mass, your energy, linear momentum, angular momentum. I think all these terms you are already familiar with. Okay. Somebody's writing here, five. Okay. What is the difference between neutron and neutrino? Yes, beta, neutron and neutrino. Both of them are different type of particles. Okay. The major difference in between the neutron and neutrino is that neutrons are made up of quarks. Okay, there are type of charged particles which are known as quarks, QUARKS. Okay, whereas when we are talking about your neutrinos, they are just fundamental particle that are not made up of any other particle. When we are talking about your neutrons, they are made up of quarks. And when we are talking about your neutrinos, they are not made up of any other type of particle. Neutrino is just neutrino, but when we are talking about your neutron, there is one more type of particle which is included inside that, that is your quarks, QUARKS. Okay, fine.
Okay, ma'am. Thank you.
So when we are coming up to your conservation laws, I was telling you that there are certain type of the quantities when we are talking about. So that is your mass. Okay. That is your charge. Okay. When we are talking about in physics, that is your energy. Okay. Next one is your linear momentum. Okay. Next one is your angular momentum. Okay. So when we are talking about all these type of the quantities, all these type of the quantities of a body, of a system are conserved. Conserved means they remain constant. All these quantities remain constant when they remain constant if no external forces applied over them. Okay. All these quantities remain constant if no external force is applied over the system in which these quantities are contained. Okay. All these quantities are such quantities which remain constant if no external force is applied over the system in which these quantities are contained. Okay. So there is a law which is governing up the conservation of these quantities. So that law is known as your conservation law. Okay. That is known as your conservation law. Right. Now, when we are talking about your conservation law, you will say, can it take place in every system? No, it is not possible for the conservation laws to take place in every system. Rather, the conservation laws can only take place inside the isolated system. Okay. There is a special type of system known as your isolated system. So your conservation laws are only applicable when we are taking up the laws when we are taking up into the consideration your isolated system. Okay, so conservation laws are only taking place inside your isolated system. So now what is isolated system? A system consisting of large number of particles, okay, large number of particles or bodies. In an isolated system, we are having large number of particles or bodies, okay. So any system on which no external force is acting is known as isolated system. अभी external force अगर मैं आपकी बात करूं तो you can say कि इस isolated system के ऊपर बेटा आपकी gravitational force भी act नहीं करेगी. जैसे कुछ कुछ एक जब हम प्रैक्टिकल्स की बात करते हैं तो वी आर सेइंग अलोंग विद इट ना कि दिस इज टेकिंग प्लेस इनसाइड द वैक्यूम. दैट मीन्स एयर प्रेशर भी उसके ऊपर एक्सर्ट करेंगे तो उसका भी कोई इफेक्ट नहीं होगा. एयर प्रेशर भी वहां पे एग्जिस्ट नहीं करता. Okay, so that type of the system is known as your isolated system. Okay, isolated system. So what is isolated system? Isolated system is that system which is having large number of particles. It's not like कि ये ऐसा system है जो खाली है, not having any type of the particles. No, it is having large number of particles inside it. So but on this system no external force is acting, so that is the reason it is known as your isolated system. Am I clear? Any doubt till here?
No, no.
Raja, any doubt till here? You can write in chat box if you're having any doubt. Okay, so after this, the first conservation law is law of conservation of charge. Okay. First law is law of conservation of charge. What this law says? This law says the total charge on an isolated system, the total charge on an isolated system remains constant. Okay, so the word isolated, mentioning up this word isolated is very much important over here. Okay, so the total charge on an isolated system remains constant. Okay, now how it is remaining constant? Let's take an example. If an uncharged glass rod, let us take an uncharged glass rod. Okay, we are rubbing up this uncharged glass rod with an uncharged silk cloth. Okay, what we are doing, we are taking an uncharged glass rod and we are rubbing up this uncharged glass rod with uncharged silk cloth. Okay, so what will happen? The glass rod which we are taking over here, okay, becomes positively charged. Okay, and your silk cloth becomes equal negatively charged. Okay, equal negative charge. So the positive charge on the glass rod is equal to the negative charge which is present on the silk cloth. For example, the glass rod attains a positive charge of 4 coulomb. So the silk cloth will be having a equivalent negative charge of 4 coulomb. ओके बेटा डोंट गेट कंफ्यूज कि जो मैम बोल रही हैं अनचार्ज ग्लास रॉड और अनचार्ज सिल्क क्लॉथ देयर आर सर्टेन टाइप ऑफ द सब्सटेंसेस व्हिच आर हैविंग पर्टिकुलर चार्जेस ऑन देम. ओके, सो वो जो इनका चार्ज होता है दैट ऑलवेज रिमेन्स कांस्टेंट, that is fixed according to the nature. Okay, those charges are fixed according to the nature, right? So when we are taking up your uncharged glass rod and uncharged silk cloth, the glass rod becomes positively charged and the silk cloth becomes negatively charged. Okay, silk cloth becomes negatively charged. Okay, so the charges which are present on them, the charges which are present on them are equal, are equal in magnitude. That means whatsoever the amount of the charge glass rod will be having, the same amount of the negative charge will be present on the silk cloth. Okay, now what exactly happens over here when a glass rod is rubbed with a silk cloth? The the glass rod loses electrons. The glass rod loses electrons. And ये आपने chemistry में भी पढ़ा है बेटा कि whatever the thing is losing up the electron, it always acquires up positive charge. Okay, it always, the glass rod loses up the electron and it becomes, when we are talking about your glass rod, so okay, we are talking about here uncharged na. So nahi, ye example nahi main aapko deti. Look here first. See beta, what we are doing here, when we are talking about, I'm telling you that if it is having plus 4C charge and it is having minus 4C charge, so what happens over here when we are calculating up the total charge on the system? Total charge on the system. So what happens? The total charge on the system becomes equal to the charge which is present on the glass rod plus the charge which is present on the silk cloth. Okay, we have taken an example that the charge which is present on the glass rod is plus 4C and the charge which is present on silk cloth is minus 4C. Okay, so in this case, what will happen? It becomes 4C minus 4C. That means the total charge on the system becomes 0. Okay, so as it becomes 0, that means the total charge on the system after rubbing becomes equivalent to 0, which is the law of the conservation of the charge. Why? Because when we were talking about the left hand side, that means when we were rubbing up an uncharged glass rod with uncharged silk cloth, so both the things over here were uncharged. That means they were not having any charge. है ना? But after rubbing them on each other, they acquired the charge. The charge they acquired was equivalent in magnitude, but was opposite in nature. So जब हमने उसका total किया, so the sum total which we are getting over here was 0. Okay, so it always obey up the law of conservation of the charge. Okay, it obeyed up the law of the conservation of the charge. That means if the glass rod is acquiring up plus 10 coulomb of charge, so the silk cloth will be having minus 10 coulomb of charge. ठीक है, जितना ज्यादा इसके ऊपर पॉजिटिव चार्ज इंक्रीज होता जाएगा, the equivalent amount of the negative charge will be increased on the silk cloth. Am I clear? Any doubt till here?
No,
Is there any doubt, anyone? No doubts? Okay. So write it down. Conservation laws. Conservation laws. Write down in this. The quantities like charge, comma, mass, comma, energy, comma, linear momentum, comma, angular momentum, etc. Linear momentum, comma, angular momentum, etc. of a body, or a system, are conserved. That is, they remain constant. If no external force is acting on the system. If No external force is acting on the system. Yes, beta.
So I kind of missed off linear momentum, etc. of a body on a system, body or a system.
Are conserved. Are conserved. In the bracket, write down remains constant.
Okay.
If no external force is acting on the system. If no external force is acting on the system. The laws governing the conservation of these quantities, the laws governing conservation of these quantities,
Sorry, ma'am, could you repeat?
the laws governing, the laws governing conservation of these quantities in nature. These laws are asked for 1 to 2 marks. Okay, just remember they can ask these laws directly in paper. Yeah, so the laws governing conservation of these quantities in nature are known as conservation laws. Are known as conservation laws. Paragraph change. These laws play an important role. These laws play an important role for the various physical phenomena occurring in nature. For various physical phenomena occurring in nature. In the next line, write down definition for isolated system. Write down isolated system. A system consisting up of large number of particles. A system consisting up of large number of particles. A system consisting up of large number of particles or bodies on which no external force is acting, on which no external force is acting, is known as an isolated system. Is known as an isolated system. Is known as an isolated system. After this, write down law of conservation of charge. Law of conservation of charge. According to this law, the total charge on an isolated system, according to this law, the total charge on an isolated system remains conserved. Remains conserved. Conserved or constant, it's one and the same thing, okay? Conserved. In the next line, write down, for example, if an uncharged glass rod, if an uncharged glass rod is rubbed with an uncharged silk cloth, if an uncharged glass rod is rubbed with an uncharged silk cloth, the glass rod becomes positively charged and the silk cloth becomes negatively charged. The glass rod becomes positively charged and the silk cloth becomes negatively charged. The positive charge on the glass rod is equal to the,
Ma'am, can you
yes,
go
beta.
slowly? Can you go a little slowly? I'm not able to catch up.
Okay, no problem. For example, if an uncharged glass rod is rubbed with an uncharged silk cloth, comma, the glass rod becomes positively charged. The glass rod becomes positively charged and the silk cloth becomes negatively charged. The glass rod becomes positively charged and the silk cloth becomes negatively charged. Full stop. The positive charge on the glass rod is equal to the positive charge on the glass rod is equal to the negative charge on the silk cloth. Negative charge on the silk cloth. Paragraph change. The total charge on the system glass rod plus silk cloth. Okay. Before rubbing is equal to 0. Okay. Total charge, you can copy it from the board. Total charge on system after rubbing is equal to plus minus. Okay, that means equal amount of positive and negative charge is equal to 0. Right? Which is the law of conservation of charge. Am I clear?
Yes.
Any doubt, anybody till here? Anyone, any doubt, beta? आयुष कुछ पूछना है? अर्जुन?
नहीं मैम, no doubts.
No, ma'am, no doubt.
Okay. आज अवनीश ने कुछ नहीं पूछा?
मैम
अवनीश, आई एम सेइंग आज अवनीश ने कुछ नहीं पूछा? कोई डाउट नहीं है?
नो मैम
Okay. Slowly, I'll come to know about I'll remember your names, है ना? For few of the students, so I'm remembering your name now. Okay. So come to the next law, the second law of the conservation, that is the law of conservation of mass energy. Okay. Law of conservation of mass energy. So what this law says, see beta, can anybody tell me the Einstein mass energy equivalence? किसी को पता है relation?
2mc square.
E equals mc square.
Yes. Very good. So according to Einstein, mass and energy are interconvertible. Okay, are interconvertible. That means mass can be converted up into energy and energy can be converted up into mass. Okay, mass of the system can be converted into energy and energy of the system can be converted up into the mass. Okay, but the sum of the mass and the energy of the system always remains constant. The sum of the mass and the energy of the system always remains constant. We already know the mass energy equivalence, that is E is equals to mc square. है ना? So E is the energy, m is the mass, and c is the speed of the light in air. Okay, so that is 3 into 10 to the power 8 meter per second. Okay, so this is the principle of atomic and the nuclear bombs. Right. That means mass can be converted up into energy and energy can be converted up into mass. And this relation, this thing, the energy equivalence to the mass, this is given by a relation, that is mass energy equivalence, which is given by E is equal to mc square. Okay. Where E is your mass and where E is your energy, m is your mass, and c is basically a constant. Okay. That is the speed of the light in air or vacuum. So this is the principle of your atomic and nuclear bombs. Okay, atomic and nuclear bombs. So atomic and nuclear bombs are based upon the principle of your law of conservation of mass and energy. Okay, mass energy equivalence is the basic concept on which all the atomic and the nuclear bombs are made. Right. So write it down. Law of conservation of mass energy.
I had a doubt.
Yes, Peter.
Can I ask, like after this topic?
Bolo beta, bolo, doubt bolo.
Okay, ma'am. So, ma'am, so we know like there's a formula where mass of a moving object is equal to actual mass of the object divided by square root of 1 minus v by c the whole square, right?
One, m is equals to m naught under the root of 1 minus v square upon c square.
Yes,
Yes.
ma'am. Ma'am. So in that, if the particle is moving at the speed of light, we get m is equal to m naught by 0.
Repeat what you are saying.
If the particle is moving at the speed of light, so if we substitute c
Hmm.
as the speed of light,
The velocity of light is substituted, is interchanged with the speed of the light. Yes.
yes, so we get 1 minus 1, which is equal to 0. So square root of 0 is 0. So we get m is equal to m naught by 0. So do we say the mass is infinite or the mass is not defined? Excuse me, ma'am.
Yes, Peter. Your voice is cracking in between. Can you please write it in the chat box, whatever you want to ask?
Okay,
To me,
ma'am.
half of your thing is audible and in between your voice is cracking. Please write it in the chat box. That will be more suitable for me to answer. Meanwhile, you can write, rest you all, keep on writing, write down law of conservation of mass energy. Write down, according to Einstein, mass and energy are interconvertible quantities. Mass and energy are interconvertible quantities. That is the mass of a system. That is the mass of the system that is the mass of the system can be converted into energy and the energy of the system and the energy of the system can be converted up into mass. Can be converted up into mass but the sum of the mass and energy of the system remains constant. Remains constant. Remains constant. In the next line, write down the energy, capital E, the energy, capital E, equivalent to the mass, small m, equivalent to the mass, small m, is given by the relation, E is equals to mc square. E is equals to mc square, where c is equal to 3 into 10 to the power 8, where c is equal to 3 into 10 to the power 8 meter per second. Ten to the power 8 meter per second is the speed of the light in air or vacuum. Okay. In the next line, write down, this is the principle of atomic and nuclear bombs. Okay. Which is the principle of atomic and nuclear bombs. Written? Beta, I'm waiting for your doubt. Please write in the chat box.
Mom, can I ask after the class?
After class, किसे पूछोगे?
I mean, like,
Message कर. Do one thing. You are having my number now. Do one thing. Just send me your doubt on my number. ठीक है?
Okay.
मैं वॉइस मैसेज में रिकॉर्ड करके आंसर भेज दूंगी.
okay, ma'am.
वैसे मुझे जहां तक समझ आया था, you were trying to ask m is equals to m naught upon under the root of 1 minus v square upon c square. You were asking इसके बाद आपने क्या बोला बेटा, मुझे वो नहीं क्लियर हुआ.
Ma'am, I was just telling that if the speed of the particle is same as the speed of light,
हाँ.
तो जो
So
equation
v square upon c square है ना, तो वो
हाँ.
क्या हो जाएगा 1 minus c square upon c square, right?
Yeah.
अब सुनो 1 minus c square upon c square, so under the root of 1 minus 1, so 1 minus 1 is 0, so under root 0 is 0, ठीक है? So m is equals to m naught upon 0, so something upon 0 is undefined.
Yes, ma'am.
ठीक
That's
है?
what I wanted to ask.
Actually your voice is cracking in between. I think it's Arjun. Huh?
No, ma'am, it's me, Ayush.
No, ma'am, it's Ayush.
Okay. पता नहीं बेटा, it's better that when you are asking ना, write it in the chat box. पर हाँ, I know we mathematical relations लिखने में it takes time. So next topic is law of conservation of energy. Next law is law of conservation of energy. So what is law of conservation of energy? Very simple and most of the time asked in paper for 1 mark. What is law of conservation of energy? Law of conservation of energy says that energy can neither be created, okay? It can neither be created nor can be destroyed. right? Energy can neither be created nor can be destroyed, but it can be changed from one form to another form. Okay, energy can neither be created nor can be destroyed. It can only be converted from one form to another form. Okay, it can only be converted from one form to another form. Let's take up an example when we are talking about the total energy of the system. So what are the two type of the energies which we are basically taking into consideration? First is your kinetic energy and the second one is your potential energy. है ना? So these are the basically two energies which we are taking. Let us suppose we are having a freely falling body, a freely falling body. Okay, so the total energy of a freely falling body remains constant. Okay, how? Suppose we are having up a body at a particular height. Okay, when a body is at a particular height, so because of height, that body is having potential energy. है ना? Because potential energy is the energy which is because of the height. So when we are considering up the height of a body, so potential energy is over there. Now, when this body starts coming down, okay, that means when its height starts decreasing, when its height start decreasing, so what happens in that case? Potential energy starts decreasing. The potential energy starts decreasing. ओके, बट जैसे जैसे आपकी पोटेंशियल एनर्जी डिक्रीज होगी, वैसे वैसे आपकी जो काइनेटिक एनर्जी है दैट विल कीप ऑन इंक्रीजिंग, दैट विल कीप ऑन इंक्रीजिंग. Okay, so now at last when we are going to calculate the total energy of the system, that becomes equal to the sum of potential energy plus kinetic energy. मैं आपको एक एग्जांपल देती हूँ. Let us suppose you are standing on your terrace. ठीक है, आप रूफटॉप पे जा रहे हो, you are standing there, you are having a ball in your hand. ठीक, आपने उस बॉल को पकड़ के रखा हुआ है. When that ball is at stationary position, तो उसकी कौन सी एनर्जी होगी?
पोटेंशियल एनर्जी.
पोटेंशियल एनर्जी, बिकॉज वो बॉडी मूव तो कर नहीं रही है. काइनेटिक एनर्जी इज द एनर्जी विच इज बिकॉज ऑफ द मोशन ऑफ द बॉडी, है ना? और पोटेंशियल एनर्जी इज बिकॉज ऑफ द हाइट. तो अभी उस बॉल की सिर्फ क्या है? पोटेंशियल एनर्जी है, बिकॉज इट इज एट अ पर्टिकुलर हाइट फ्रॉम दैट ऑफ द ग्राउंड लेवल. ठीक, अब when you are throwing that ball, वो एकदम से डायरेक्टली आके तो ग्राउंड फ्लोर पे नहीं गिरेगी, है ना? It will take certain fraction of seconds or few seconds to come and fall on the ground surface. ठीक है, in between क्या हो जाएगा? जैसे जैसे आपकी बॉल is coming towards the ground, उसकी जो हाइट है वो क्या हो जाएगी? डिक्रीज हो जाएगी. Right, when the height is decreasing, simultaneously जो आपकी बॉल है उसने मूव करना स्टार्ट कर दिया. अब जब एक बॉडी मोशन में आ गई तो ऑटोमेटिकली उसकी काइनेटिक एनर्जी भी है, उसकी काइनेटिक एनर्जी ने इंक्रीज करना स्टार्ट कर दिया. और जैसे जैसे उसकी हाइट कम हुई तो पोटेंशियल एनर्जी ने डिक्रीज करना स्टार्ट कर दिया. So both the things, your kinetic energy and potential energy are taking correspondingly. जैसे जैसे हाइट डिक्रीज हो रही है वैसे वैसे काइनेटिक एनर्जी इंक्रीज हो रही है. दैट मींस as soon as the potential energy of a body decreases, the kinetic energy of the body increases. Right, अब जब आपकी बॉल when it is coming to your ground level, so at that particular time the maximum energy attained by the body is kinetic energy, whereas when the ball was in stationary position in your hand, the maximum energy attained by the ball was potential energy, है ना? Now the total energy of the system is getting converted up into your kinetic energy because of the motion of the body, right? So that means as soon as your potential energy decreases, kinetic energy increases. Okay, so according to this law, the energy has only, there is only the conversion of the energy taken place. That means earlier it was potential energy, now it has been converted up into kinetic energy. Nothing else is that. Okay, so that means energy can neither be created nor can be destroyed, but it can only be changed from one form to another form. Clear? Any
Yes,
doubt?
Yes.
Okay, so write down law of conservation of energy. Now, beta, all those who are every time quiet now, I won't let you quiet every time. I'm going to take oral test also in class. Written तो दोगे ही, एक दिन मैं आप oral test रखती हूँ after completion of this chapter. Let me also know कि कितना समझ आया है ना? Okay, so write down according to this law, energy can neither be created nor can be destroyed. Energy can neither be created nor can be destroyed, but it can be changed from one form to another. But it can be changed from one form to another. In other words, total energy of the system moving under the conservative force, total energy of the system moving under the conservative force remains the same. For example, the total energy of a freely falling body, remains constant when a body is dropped from a certain height, comma, its potential energy goes on decreasing, but the kinetic energy goes on increasing. Full stop. But the sum of kinetic and potential energy, that is the total energy of a system, at any instant, the same. Okay. Clear till here?
Yes, ma'am.
Come to the next one. That is law of conservation of linear momentum. Beta, it will take 5-10 minutes more, but I want to finish up it today. So please cooperate, huh? 5-7 minutes extra लग जाएंगे, but मुझे आज ये finish करना है. Next is law of conservation of linear momentum. So, what is the formula for linear momentum? Can anyone tell me what is the formula for linear momentum?
Mass
Already
into
किया हुआ है बेटा.
acceleration.
Beta, that is force. Force is equal to mass into acceleration. I'm asking about linear momentum. Linear momentum is represented by P vector. है ना? So P vector is equals to M into V vector. ठीक है? P is equals to MV. This is your linear momentum. Okay. So linear momentum is what? It is the product of mass and velocity of a body. Okay. Product of mass and velocity of a body. Right. Now, according to this law, the total momentum of an isolated system, the total momentum of an isolated system always remains conserved. Okay? Always remains conserved. Now, the example you have already done in 9th standard, recoiling of the gun. कुछ याद आ रहा है 9th standard में किया था बेटा? Rocket propulsion. याद आ रहा है कुछ?
Yes, ma'am.
Applications, these applications you have already done, है ना? A gun, why the gun is see beta, when a gun recoils, है ना? A gun recoils when bullet is fired from it. A gun recoils when the bullet is fired from it. Okay. Before firing, okay. So when we are taking up your system, so in a system, it is before firing. So system is your gun plus bullet. Okay. Before firing, so gun plus bullet, they are at rest. They are at rest. Okay. So that means the linear momentum over here is 0. Linear momentum over here is 0. Why it is 0? क्योंकि body move ही नहीं कर रही है. If body is not moving, तो velocity 0 हो जाएगी. है ना? If velocity is 0, तो automatically आपका momentum 0 हो जाएगा. Right. Now, when we are talking about after firing, what happens after firing? The bullet moves forward. Bullet moves forward. Okay. Bullet moves forward with a very high velocity. Okay. So, in order to conserve the linear momentum of the system, the gun moves in the backward direction. The gun moves in the backward direction क्योंकि उसको उसे balance भी तो करना है. If bullet is moving in the forward direction, in order to balance it, the gun is recoiling in the backward direction. Am I clear?
Yes, ma'am.
That why before firing the system is having linear momentum as 0, because before firing there is no velocity. If velocity is 0, linear momentum is automatically 0, right? After firing, bullet is attaining particular velocity. It is moving in the forward direction. As it is moving in the forward direction, in order to balance it, the gun is moving in the backward direction, right? So write it down. Law of conservation of linear momentum. Law of conservation of linear momentum. Write down. Linear momentum of a body is the product of its mass and velocity. Linear momentum of a body is the product of its mass and velocity. Full stop. That is, P vector is equals to M into V vector. That is, P vector is equals to M into V vector. According to the law of conservation of linear momentum, according to the law of conservation of linear momentum, the total momentum of an isolated system, according to the law of conservation of linear momentum, the total momentum of an isolated system remains conserved. Remains conserved. For example, a gun recoils. A gun recoils when the bullet is fired from it. A gun recoils when the bullet is fired from it. Full stop. Before firing, comma, the system, in the bracket write down, gun plus bullet. Gun plus bullet is at rest. So the linear momentum is zero. So the linear momentum is zero. Full stop. After firing, comma, the bullet moves forward. The bullet moves forward with a very high velocity. With a very high velocity to conserve the linear momentum of the system. To conserve the linear momentum of the system, comma, the gun moves backward. The gun moves backward. Written beta?
Yes.
Any doubt till here?
No
No,
doubt.
ma'am.
So that's all about your unit 1. Okay, chapter number 1. It's finished over here. Just go through this chapter from your NCERT textbook. Okay, and the book which I refer is either you take SL Arora or you can go for Pradeep's. Okay, both the books are good. But at this point of time, I won't suggest you your HC Verma. You can go through that book, but after a certain period of time. Okay, because difficulty level of that book is not your beginner's level. Okay, that book is not meant for beginners. That means you are just at the start of your 11th standard, right? So that book is not recommended right now, but you can have that book after your half of the session is over, right? That means around the month of your October or November, you can have that book. Okay, but at this point of time, you should have SL Arora or Pradeep's. Both the books are good one.
Mom, do you recommend DC Pandey?
Yes, ma'am. Should I buy DC Pandey?
actually, that is not a book which is up to the mark. S.L. Arora and Pradeep's. Both the books are good ones because the reason is you will find a lot of MCQs for your entrance exams in these books. These books are very good books. Or otherwise, what you can do if you are having a library at your school and you are getting books issued from there. So what you can do, you can buy any one of the book and then you can get another books issued from your library for 7 days or 14 days to go through any of the particular chapters. Or otherwise, all the books are available online in PDF formats. Okay. Your school people are asking you to buy that DC Pandey?
No, ma'am. I spoke to one of my friends who is in an IIT, and he told he has used DC Pandey, and most of his batchmates have used DC Pandey. That's why.
Because that book is basically for objective physics. DC Pandey, that book is basically used for objective physics when you are preparing for your entrance exam. But at this
Exactly,
point of
ma'am. Only
time,
for
if you're
entrance.
beta at basically the book I am telling you is you are asking for the entrance exams.
Yes, ma'am. For
Entrance
entrance exams.
Objective. The book which I am telling you is not meant for objectives. It is not just meant for objective. It is having both subjective as well as objective. S.L. Arora and Pradeep's are having both subjective as well as objective.
Ma'am, there's a series of DC Pandey, which is a 5 volumes.
Yeah, I know. There is series of these books, but beta, these books are not recommended for your, you can say for your main exams, for your board exams. Okay.
Can we
Likewise,
use
so,
them for JEE?
huh?
Can we use them for JEE preparation?
Yes, ma'am.
Yeah,
We
for
are
that too
talking
you can
from
use.
JEE.
For that too you can use, but I'm telling you S.L. Arora and Pradeep's for your syllabus, from the syllabus point of view.
Ma'am, so should we buy S.L. Arora for boards and DC Pandey for entrance exams?
You can buy DC Pandey for that. You can buy H.C. Verma for that. Both the books are good one. Even you can buy Arihant. That is also a good book.
Ma'am, so would you
See,
Ma'am,
beta,
DC Pandey is not one.
beta, let me tell you, let me make one thing clear to you. Actually, what is done in all these books now, there are large number of repetitive questions. Okay. Whatever the questions you are getting from last so many years, so those questions are repeated over here.